Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math related. And today we're doing physics, and we're going to talk about light. Nathan, if you would get me some water, I would appreciate it. Should have got that before. Anyway, and see, you'd think I'd start over, but I'm not going to, because, you know, I just whip these videos out. I got too many to make. I'm doing 9 classes of video, 10 if you count the calculator lab. So, gotta make sure these get out and that the homeschoolers and anybody following them can keep up with their work. So no time for redos, one shot. All right, so we're talking about light, and we've been talking about waves. And we talked about there's 2 kinds. There's transverse waves, that's fun to do, and compression waves. Zoom, 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 zoom. It's more fun with sound effects. Well, sound we learned were the compression waves. Zoom, 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 zoom. Light is the transverse waves. So if you live in the Atlanta area, which a lot of you do, because I know a lot of you had my classes I was doing, and now you're doing the YouTube classes instead. We went to YouTube originally because of COVID, and then my situation changed, so it worked better to keep it on YouTube. But anyway, we have in the Atlanta area a terrific museum called Fernbank. It's mostly dinosaurs and things like that, which those are fun to look at, those dinosaur bones. There's a huge one called an Argentinosaurus that's just excellent. I like it so much. But anyway, they have different display rooms, and I think it's on the 2nd floor. They've got one just for physical science, and physics is a physical science, physics and chemistry. And in it, you can go play with all these light things. So like in the book, they've got someone's hand, and then the light is coming from different sources, and you can see the different colors, the pink, the turquoise, the green, the yellow. Well, they have a wall where you can do that at Fernbank. So that's really fun. And they got all kinds of other stuff. So I highly recommend that maybe even wait till spring when the weather is a little bit better, and make sure they've reopened for COVID. But I highly recommend going to Fernbank and going and spending a day, or spend, you know, part of the time, a few hours in that physical science lab. A lot of the things we talk about that you're not going to have the equipment to be able to do, and I don't even have the equipment to do as a public school teacher, they've got in Fernbank. So, you know, some of their worldview stuff I don't agree with, but the dinosaur bones are cool, and so is the physical science stuff. So that's up for you and your family to figure out the worldview stuff. But love that museum. We I think had season passes one year. One year we just ended up going a lot. No, it was a friend of ours had seasons passes, and they had seasons passes where they could bring a friend, and we were the friend. So we got to go a whole bunch one year. It was really cool. All right, so back to light. Transverse. So even if you don't live in the Atlanta area, there are other museums that have this. I think there's one in maybe Augusta, Georgia, is it like a Discovery Science Museum. I think there's one in Birmingham. So I know there's one in North Carolina because I went to it with my friend Karen. I don't remember what city we were in though. I know where she lived. I remember we went, but I don't remember where. It might have been Raleigh. So anyway, a lot of the big cities that have museums have the science centers. And just because you primarily think of it as biology, like the dinosaurs, there's a good chance that they'll have the physical science hands-on stuff. Now, we also have here in this area Tellus Museum. But they're more a rock museum, and I don't think that they've got so much physical science stuff like Fernbank does. It's a lot closer, though, to where I live, and a lot less traffic. If I had a choice, I'd go to Tellus because it's closer. All right, so when I say light, I don't just mean Roy G. Biv. Now, there's a song. You should go look it up on YouTube. It goes, Roy G. Biv is a colorful man at the rainbow's end. It's by They Might Be Giants. I'm sure it's out there. You need to go hear that song. But I'm not just talking about Roy G. Biv. I'm not just talking about visible. When I say light, I mean the entire electromagnetic spectrum. So that is not Roy G. Biv. It's Ronald McDonald is very ugly, extra gross. So Ronald, what can I say? I don't like clouds. Ronald is radio waves. So radio waves are not sound waves. That's why when they play the radio station in Atlanta, we can hear it way out here in the country instantly, because it's not moving at the speed of sound, which is really slow. It's moving at the speed of light, which on Earth is so small, it's instant. Like once you start talking about the distance to the sun, it takes a few minutes for the light to get here. But Earth's too small. Light is pretty much is instant. We'll talk about that a little bit more. So the first one is radio waves. And then those radio waves are transmitted into electric impulses, which then are changed into sound waves so you can hear it. Ronald, radio. McDonald, microwave. So when you are heating up your baked potato in the microwave oven, you're actually using light waves to vibrate the food to really the water molecules in the food and to heat it up. Ronald McDonald is infrared. That's heat. When you feel heat, you're feeling infrared. Ronald McDonald is there's your visible light, Roy G. Biv, and it is a tiny sliver, much smaller than it even looks in the diagram in your book, of the spectrum, which is really amazing to think that an eyeball would have evolved to see light of that tiny spectrum that it didn't know was there. Amazing. All right. Ronald McDonald is very ugly, is UV light. That's what tans your skin, darkens it, and also causes cancer. So stay out of those tanning booths. They're really bad for you. Just be happy with the color you are. Don't try to change it. Okay, use sunscreen. Ronald McDonald is very ugly, UV, extra X-rays. So, you know, when they take a picture of your bone, your teeth, they're using light, X-rays, and then gross, gamma rays. So, you know, that's what turns Bruce Banner into the Hulk, right? They're also just really high energy waves from the sun. And so the sun and other planets put out all of those wavelengths. So when you hear static on the radio, you're hearing sun radio. S-U-N, sun radio. You're hearing the static, the radio waves produced by the sun. That's what static is. Isn't that cool? And TV waves are a type of electromagnetic spectrum too. It's down there at the radio waves end. So TV signal is also a type of this. And our cell phones. Okay, so how they figured out the speed of light in a vacuum. Now, light changes speed depending on what it's going through. But if it's not going through anything, it's speed of a light in a vacuum. And the symbol for it is lowercase c, so equals mc squared is the c. And it's 3 times 10 to the 8th power meters per second. And you can think of it, I think it takes 8 minutes from light from the sun to get here. So if the sun blew up, we'd have 8 minutes to live before, I guess, maybe not, before it goes dark. And then, you know, then we go dark, we go cold. I'm pretty sure there's a Twilight Zone about this, about some lady who can't see or something. Anyway, did y'all ever watch this? I like the ride at Disney. All right, focus. Okay, so sources of light. The source of light, how light is measured is its lumens, lumens illuminate something, things that give off light. A lot of light is given off by electrons jumping out of their orbitals. So if you want to know more about that, there's a chemistry video about it. So I don't know if we've got there. We haven't gotten there yet in chemistry, but there will be in a few weeks, and you could learn more about it. But there might be on my other I have 2 chemistry channels. One for the homeschoolers, which is called Chemistry Lessons, and one for my public school class that I teach called Elements of Chemistry. And Elements of Chemistry might have a video on it. If not, wait, they'll both have one soon. You can learn more about it. Or most of you have already had chemistry because you take chemistry normally before physics. Okay, your lab this week, you're going to make a pinhole camera. And if you had some old-timey film, you could actually make a picture. But even without film, you can see the image. So I want you to do it. It's made out of common everyday things, and it's cool. So I want you to do that. The closer you are to a light source, the brighter it is. You can think of it, your book has it as a ball going out, and as it goes out, it gets thinner and thinner and thinner. The physical science book that I teach out of has spray paint. And if you spray paint on a wall, the closer you are, the darker that paint is. The further you move back, the lighter it is. And it's the same with light. Light gets less the further you are away from it. We'll have another video where I'll do the math with this. The math in this one is not so much. It's as we go on and talk about reflection and refraction, we're going to have a little bit more math. It's one of the harder parts. Well, it's not really the harder parts, but a lot of people dislike this part of math, of physics, because it's got fractions in it, and a lot of people don't like fractions. Now, I had one student last year in one of my math classes who loved fractions, so if that student's taken the physics, get excited. We're about to do fraction math. Yay. Do y'all get my shirt? It's not Christmas, but I wanted to wear it anyway because it's kind of mathy. It's fa la 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 la. One of my students made that for me. All right. So light matter. Okay, so now let's talk about mixing paint is different than mixing light. Okay, so if you have paint, you were in preschool and you learned that if you mix red and blue, you get purple. If you mix red and yellow, you get green, and if you mix yellow and you get orange. I'm thinking ahead, the other one. And if you mix, I have a cat here, see the cat tail. If you mix red and blue, you get purple. Red and yellow, you get orange. And blue and yellow, you get green. Okay, I said it now. Didn't get distracted with the cat. Light is different. If you mix red, I'm going to have to move the cat because the cat is running in to the camera. You can see the cat. Everybody say hey to the cat. There's Ruby, the cat. Okay, she's got to go. Off she goes. Thank you, Eli. Anyway, with light, if you mix red and green, those are our primary colors, you get yellow. If you mix blue and green, you get kind of a green-blue color. And if you mix blue and red, you get this purpley color, magenta. Then if you mix those three colors, you get white light. So it's different. And there's a thing at the Fernbank Museum where you get to do that, and that's fun. Another thing is printing. Printing ink mixes colors different too than the old paints, the tempera paints you used in preschool. And what they do is when you see a printed photograph, it's made out of little dots of just 3 colors of ink. And if you got close enough, it would be like one of those impressionist paintings with all the little dots, but your eyes blend it together. Your eyes blend light. So like if you look at a waterfall, it just looks white and swooshy down. Your ears don't. Your ears keep sounds more distinct. And so you have to blend the sounds yourself, like with a musical instrument. But if you can get flashy light, a strobe light, then you can see the little individual water droplets. So we used to do that in a physics class I taught, where we would get a strobe light. You can get them cheap at like Party City. And then we would attach a hose onto our sinks that had like little jets to them, and put our thumb on it so it makes just a spray. Put the strobe light on it, and it would look like the little pieces of water were just hanging in the air. And if you adjusted the strobe just right, it would look like they were crawling back into the hose. So very messy, but lots of fun. But when I just taught physical science in public school, the curriculum that we're using now is much more emphasis on chemistry than physics, so we didn't get to do any of those fun physics. We didn't do much physics at all, very little. So, because of COVID, it wasn't our fault, it wasn't the kids' fault. With COVID, we kept having to go home, and then that would delay. We would still keep working, but you couldn't work at the same pace at home, so we didn't get to do as many fun labs. All right, so remember that I told you that the speed of light is the same in a vacuum. But when it hits different mediums, it will slow down depending on the medium. And that causes the white light split into the rainbow. So if you put white light through a prism, a little glass triangle, you can see the rainbow. You should go and have a little extra assignment. I'll try to remember to put in your homework, to go on a rainbow search. Go try to make rainbows and try to find rainbows in your house. Find that crystal glass that makes rainbows. Find the beveled edge of the antique mirror or antique piece of glass. See if you see some rainbows. Go out in the yard, put the sun to your back, and spray the hose in the late afternoon or early morning. See if you can make a rainbow. Go on a rainbow. Go hunting rainbows. Doesn't that sound fun? I'm hunting rainbows. It sounds like you're doing something very, spiritual or something. But anyway, as light changes speeds, then it splits into the colors. So that's how you get the rainbow. Another way you can get rainbows is called thin film. And we have this a lot in Georgia. It's summertime. Everybody drives all yucky cars like us, and they leak oil in the parking lot. And then it rains after not raining for a while. And what do you see all over the parking lot? Oil rainbows. You got to find rainbows where you can. Sometimes they're in the oil in the parking lot. Now, I have a friend who lives up north where they have a lot more government regulation, and they're not allowed to drive yucky old cars like we do in the South. And also their cars rust out faster because of the snow and the salt and all of that. So they don't have the old beat up cars that we have in the South, because in the South, we haven't had snow in several years now. So we don't have the salt on the roads or anything like that. So she came and she was visiting me, and she said, wow, this is really weird seeing all these old beat up cars. We don't have that up north. I'm like, welcome to the South. So anyway, you see that the cars in the South are dripping oil in the parking lot. It rains, and it's called a thin film rainbow, and you can see the colors in it. You can see it in a soap bubble. That's one of the places you can look for rainbows. Oh, what's really fun is to take the bottle of dish detergent and go and like make it where it's blowing air out, and it'll make little bubbles go everywhere. And if the sun's just right, ooh, rainbows everywhere. It's so fun. So ask your mom's permission before you're shooting bubbles all over her kitchen. But if I was your mom, I'd let you do it because it's science. Anyway, so that's really fun. Okay, so here's another thing about light is Polaroid. The cameras. Well, Mr. Polaroid figured out something else before he figured out the cameras, and it was Polaroid filters. And he was a scientist. He knew a lot about chemistry and physics and about light. And he figured out that one of the problems, like with driving and stuff like that, is glare coming off the road. Now, if you live in a very flat place, very hot place, Arizona, Florida, someplace like that, Texas, I think we have some Texas people watching, then you will often see this heat and glare coming off the road. Here we don't have it so much because where I live, it's very hilly. We're in the foothills of the Appalachian Mountains, and so there's not those flat stretches of road very much with the glare coming off. But if you have flat stretches of road, then the light can bounce off of the road up into your eyes and make a glare, and it's very tiring and terrible, especially with driving. So Mr. Land invented these cameras, this film, this filter with little bitty slits in it where the light can only go through if it's aligned the right way. And then he oriented the film in sunglasses so that it can't glare off the road into your eyes. So they're Polaroid sunglasses or polarized filter. Once the light has gone through the filter, and it's like doing a slinky through a picket fence. It would have to line up with the holes in the picket fence for the slinky to be able to go up and down. So it gets rid of all the light, the glare light. So you can buy Polaroid sunglasses, polarized sunglasses, and all those expensive ones like Foster Grants and Ray-Bans, all of those, they have the filters. So if we were in class, what I would do is I would give you two of them. I have them where I've poked them out of cheapo sunglasses, not the expensive ones. I got the lenses. And if you put them where the slits are together, the piece of sunglass looks very light colored. But if you turn it, where you take one and turn it, it goes black. And it's because you're making it where the light can't get through this picket fence anyway. The little slits aren't lining up. And there's probably videos on this on YouTube you can look at. So take a look at that. If you got some old Polaroid sunglasses, you'd have to take the lenses out. So ask your mama, and you could turn it and you can see it. So that's a fun little thing to do, the polarization of light. And you can see it in your book, and I'm sure there's pictures on YouTube and probably videos too. All right, so come back and we'll have another video with the math of this chapter. And like, share, and subscribe. Science is great.